Not missing any of those, so we're just going to carry down 1. 1 times 4 is 4. 4 minus 3 is 1. 1 times 4 is 4. 9 plus 4 is 13. That's my remainder. My quotient would actually be x plus 1 would be my quotient. And more specifically, if I needed to, I could say my function, if I plug in a positive 4, would equal 13. So if I plug 4 into that equation, I should get 13 out, which would be 16 minus 12 plus 9, which does equal 13. All right, questions from the homework? Nick?
Yes.
Number 1.
5.
Oh. All right, number 5. Let me go through real quick. What would be a good example? Let me go through number 1 really quick, but I'm going to take a picture of it because I think we all got that one. I'm going to talk about number 1 first, and then I'll go back to that one for a specific reason. So with number 1, and this is how we always did it. We said, well, if I have x minus 2, I need to have x squared, I need to have an x, and I have a constant. So if any of those are missing, I had to put a 0 in. Well, the reason we had to do that is because the x and the 2 are actually 1 power apart. This x is x to the first. This 2 is actually 2 times x to the 0th power. These are 1 power apart. So what I'm dividing into has to be 1 power apart. So i.e. x squared, x to the 0th. That being said, s squared, negative 5 are actually 2 powers apart. There are 2 powers apart because this is s squared. 5 is, you could think of that as being 5 times s to the 0th power. It is 2 powers apart. Since what I'm dividing by is 2 powers apart, what I'm dividing needs to be 2 powers apart also. So it needs to be s to the 4th minus 3s squared plus 6. If you put a 0s to the 3rd in there, it got messed up really quick, right?
Because originally I did it like that, and then I was like, shoot, I missed the s to the 3rd. So then I did it wrong.
And that messed it up, right?
Yeah.
It messed it up, which would have told you maybe try it this way. This way actually works because now if I do s squared out of s to the 4th minus 5s squared, I am subtracting. That would give me 0. I would actually have positive 5s squared, negative, so I have 2s squared plus 6. So this would be plus 2 up here. That would give me 2s squared minus 10, but I am subtracting this. So that's going to be 6 plus 10, which would be 16. Now I have an answer. Does that clarify what I would have to do with that? So if I had s to the 3rd, and a 5, this better be by 3s. I should have count down by 3s. Okay? And I'll set it up that you can actually solve it, and it's not impossible to solve. Mm-hmm. All right, other questions from the homework? Yeah?
So then, like, the question will never ask me to divide
No.
one that wouldn't work?
Right, correct. So let's put in the box, maybe an example I might do is maybe I would say, let's do, let me check real quick. Yeah, I think this would work. If I did like s to the 6th plus 5, x to the 3rd minus 6. I could divide that by s to the 3rd minus 4 because the power between s to the 3rd, x to the 4th would be a skip of 3, kind of. Can you picture that? Yeah. And so 6 minus 3 is 3. 3 minus 3 would be 0, so I could divide it right into there because each one has a difference of power of 3. Did I confuse you more? Or it would work. This would work. Yeah. I'm not going to try to confuse you on the test and be like, psych, you can't do it. Hope you didn't waste 10 minutes on that. All right, other questions from the homework, though? All right, then we'll get to today's lesson. Today's lesson is on using the factor theorem, and I very crappily put that on this page. But you have it right in front of you. The factor theorem. The factor theorem says the number c is a 0 of the polynomial function y equals px if and only if x minus c is a factor of the polynomial p of x. Whew. So what we're saying is when we do our division, if our remainder comes out to 0, it is a 0 of our polynomial, i.e. it is a factor. And we'll see what that means in just a second. So we're doing the same thing, but if our remainder comes out to 0, it goes in evenly, so it's a factor. So it's something I can actually pull out of it. Let's go back to here. All right. We're supposed to check to see if x plus 4 is a factor of x cubed minus 13x plus 12. Hint, hint, it is, because then it says also factor it. All right, we're going to check to see if it's a factor. We can do ordinary, don't write this, well, you can if you wanted to. We could do ordinary division, in which case we do x plus 4. I am not going to do this, but you could. Excuse me. So we could do ordinary division. I'm going to use synthetic just because it's a little quicker. To use synthetic, I have to recognize that x plus 4 is really checking for p of negative 4. So I actually have to, for synthetic, I actually have to divide by a negative 4. And the way I think of that, while we're doing a negative 4, is because I'm looking at what do I plug in for x that would make this 0. And so I'd be using a negative 4 to make it 0. So we're supposed to check if it's, so we have x cubed minus 13x plus 12. Well, we have 1x cubed. We have, don't forget about your 0x squareds, negative 13x's, and 12 constants. If you need to, just write it above. Right? That's my x cubed column. That's my x squared. That's my x. That's my constant. There are no points taken off because you're putting extra work down. I promise you. If anything, it helps me score your points the more work you put down. All right, let's go ahead and run through this. I would bring down that 1. Boom. Negative 4 times 1 is negative 4. 0 minus 4 is negative 4. Negative 4 times negative 4 is a positive 16. Negative 13 plus 16 is a 3. Negative 4 times 3 is negative 12. Boom, boom, boom. My remainder is 0. Since my remainder is 0, x plus 4 is a factor. And since it's a factor, we can actually rewrite this. And how we're going to rewrite it, we're going to do it over here. I'm going to say, well, guess what? X cubed minus 13x plus 12. I'm going to rewrite it. I am going to rewrite it. And I'm going to rewrite it as x plus 4 times something. David. I would agree with that. And that comes from our quotient. That comes from our quotient. So all David did is he looked at this part and he said, well, this is just 1x squared minus 4x plus 3. That's my quotient. So divisor times the quotient equals the original thing.
It's just like an extra step to what we did yesterday.
Yeah. Yeah. Except this time we're hoping it comes out to 0 so I can pull it out. The only time you can rewrite it like this
Is if it comes out to 0.
is if it comes out to 0. But we can go one step further now. we can factor the other one. Why is that important? Well, good question. We know how to find the zeros for a quadratic function, right? We can complete the square. We can use the quadratic formula, and we know how to factor those. That's what we practice with. I started with x to the cubed. Does the quadratic formula work for cubed functions? No, it doesn't. Completing a square doesn't work for cube functions either. If you can see it, it's really hard to factor these, but we can't really factor these. Our whole goal today is to turn something that's like x cubed into something we've used before, and that's a quadratic. All right, so we're turning something that's not a quadratic into a quadratic so we can deal with it. So right now we can actually deal with this one. We can actually factor it further. X to the fourth times x minus, 3? X minus 1. Now if I ask for your zeros, you would just say my zeros of this one are -4, 3, and 1. I found all of those zeros.
So do we just put that in the bracket?
If you want to, I'm just asking you to factor right now. I'm just saying in the future, and we will today, but if you want to put that in there, there's nothing wrong. There's nothing wrong with putting more on your sheet than I write on here. Remember, I'm saying stuff. I'm just saying what work. I'm also talking. The next thing we're going to talk about, so now we know how to kind of factor polynomials. If I know 1, 0. Now we're going to talk about the rational zero theorem. And we're going to build up to it. So I have 6x squared minus x minus 35 equals 0. I already factored it for you. You're welcome. You're welcome.
I said thanks.
I know you did, but not everyone. No, I'm just kidding. I heard Jack and you. All right, so I factor that. And so that equals 0. So I have an x of 5 over 2 and an x of -7 over 3. Here's where it gets interesting. Let's look at 6. I want to put 6's right here. 6 is divisible by 2
Oh my gosh, it's the denominator.
and 3. Now let's look at that 35. 35 is divisible by 5 and 7. Do you think this is a coincidence? A coincidence. I got too trigger happy on all those. It is not a coincidence. It is not a coincidence, and it is the backbone of something called the rational zero theorem. Let's run through what the rational zero theorem is. If p of x is a polynomial function with integral coefficients, with the leading coefficients and constant term is not 0, and p divided by q is the rational zero of p of x, then p is a factor of the constant term, and q is the factor of the leading coefficient. Nailed it. We're all good? How do you have a question? I just explained all of it to you. No, yeah.
But, so we'll, think about this for a second, because 6 can be 1 times 6
Yep.
or 2 times 3.
And we'll see that.
So you can have a 1 times 6, maybe?
Yeah. Yep. And that's what we'll get to with me putting this a little more clearly, and then we'll actually do a realistic, real world, not really real world, but a problem with it. All right. Maybe a little more clearly. Let's say I'm looking for rational zeros of 3x to the fourth plus x plus 4. Any rational number can be written as p over q. So I'm saying any rational number can be written as fraction. So if I have 4, I can write it as fraction of 4 over 1. So I can write anything as a fraction where both p and q are integers. Do we believe that?
Yes.
You can. That is 100% true. All right. So each of our rational zeros can be written in the form p over q. What this theorem says is that 4 must be divisible by p. So my p that's on top must be able to go into 4 evenly. So that's a 1, a 2, or a 4. And 3 must be divisible by q. So q must be something that goes evenly into 3. So that's 1 and 3. So my numerator needs to be divisible by 4. my denominator needs to be divisible by 3. That takes the whole world of infinite numbers down to a much smaller, more manageable thing of possible rational zeros. Let's do an example. So we have f of x equals 3x cubed minus 8x squared minus 8x plus 8. It says find all the zeros of the polynomial function. Here's the problem. We have it cubed. So I can't go plug in the quadratic formula. I got this. That doesn't work. We have an a value, a b value, a c value, and a d value. So we can't plug this. We can't complete the square. Factoring is going to be hard. So we're going to go to something called the rational root theorem. We're going to come up with a list of all our possible rational numbers. And what we're going to do is we're going to first find all the factors of 8. Then we're going to find all the factors of 3.
Is it the intersection?
It isn't the intersection. It's actually all of them. It's going to be the union. So the factors of 8 are 1, 2, 4, and 8. So my numerator can have a 1 in it, a 2 in it, a 4 in it, or an 8 in it. My denominator, well, that's nice. It's just 1 and 3. When we're doing this, you're going to be very happy when you have ones that are just 2 things. Because we now have to write fractions for all of these. We're going to write fractions for all of these. And what I mean by that is I'm going to do 1 over 1, 1 over 3. 2 over 1, 2 over 3. But there are going to be repeat ones. So let's go ahead and make that list. Let's start with our 1. So we have 1 over 1, which is just going to be 1. Then I'll do 1 over 3. Then we'll go back and do 2 over 1, which is 2. And then we'll go 2 over 3. Then we'll go 4 over 1, which is 4. 4 over 3. 8 over 1, which is just 8. And 8 over 3. You could, if you're very, very particular about how you do stuff, order this from lowest to highest. I a lot of times just leave it in this order, especially when there's this many numbers. Here's the problem. We have to add to this list. Because we don't know if the 0 is a positive or a negative. So it could be positive or negative 1. Positive or negative 1/3. Positive or negative 2. Positive or negative 2/3. Now you might be grunting and groaning that you'd have to check all these to see if they're zeros. But realistically, imagine how much easier this is than checking an infinite number of them. Right? So let's just check 1. I always start at the beginning of my list. Let's try, pick 1. Pick one of these to try. 1? Okay. Let's try 1. I always pick small ones too. So we are going to use...
It's not.
Isn't it going to be 1? No, it isn't.
Negative 5.
But hang on. We're going to test 1. So this is just a test. 3, negative 8, negative 8, and 8. So this is 3. 3 times 1 is 3. Negative 8 plus 3 is negative 5. Negative 5. Negative 13. Still negative 13. Ugh. Negative 5. Not a 0. And what we'd need to do, if I didn't have a calculator, I would have to check every one of these to see if it's 0. Most of the time, there's not this many. All right, a lot of times if I'm using the rational 0, it's usually like 4 or 5 that I have to check. But you have this awesome thing in your calculator that will graph this for you. And that is our y equals. So this would be guess and check. We aren't going to use guess and check. We're going to use our calculator to get our actual.
Then do we use the vertical line thing to see if it's a function or not?
No, we already know it's a function. I said it's a function.
Okay.
So I want you to take out your calculators.
Should we just plug the equation in for a while?
We are going to plug the equation into the y. Yes, we are.
Oh, it's right
So you're going to plug that full equation into your y, and then you're going to graph it. Um, Tomorrow we're going to learn an even quicker way to do this. One, you can just sit there and just stare at the board and then you get the answer, but
That's not very useful.
no, it isn't. But let's type this in as quick as we can because I'm waiting. 0 and 1. Do we all see that point that I'm looking at?
Yeah.
The 0 right here. It's somewhere between 0 and 1. So I'm going to go to my list. And I'm going to look for values that are between 0 and 1. Well, that's 1/3 and 2/3. Does that point look closer to 1/3 or 2/3?
2/3.
It looks closer than 2/3. So by the calculator, by just looking at the graph, we are going to hope that 2/3 is going to be, maybe I should put this arrow here. So I use my calculator to come up with a prediction that 2/3 is my 0. This is guess and check. You have to run through all of them. So maybe put a note that if you don't have your calculator, you do have to guess and check your way through it. But if you have your calculator, we're going to let our calculator do some of the heavy lifting for us. Our calculator says, hey, check 2/3. That might be a 0. So let's try 2/3. So let's try 2/3. We are going to use synthetic division. We still have 3, -8, -8, 8. So we have -8, and then an 8. I would carry down that 3. 3 times 2/3 is 6 divided by 3, which is going to be 2. I have -6. -6 times 2/3 would be -12 divided by 3, which is -4. -8 is going to be -12. -12 times 2 is -24. Divided by 3 is -8. Guess what we have? It works.
And then 4/3, I bet.
No.
Oh,
Let's just hold on.
okay.
It could have worked, but it actually wouldn't work. If we try 4/3, it won't work, and this is why. As soon as I find 1, 0, I'm going to let algebra do everything else for me. So right now, 2/3 works, right? So I can now rewrite this equation. So I started with 3x cubed minus 8x squared minus 8x plus 8. I can rewrite this as x minus 2/3 because we know that's a factor. And I'm going to multiply that by 3x squared minus 6x minus 12. Because I got that from right here. Are we all okay with that? It's kind of a big jump.
So is that the final answer?
It is not the final answer because I haven't found my zeros yet. I found one of my zeros, right? It says find all your zeros. I have one, which is 2/3. I'm going to jump to my next slide just because I ran out of room. I'm going to copy everything down here. So if you're missing anything, I will put it on the next slide. Nope, that's a black dot. Paste. All right, so I'm right here with you. Well, I'm trying to find my zeros, so let's just make this equal to 0. So either my x equals 2/3, or this big section here, 3x squared minus 6x minus 12 equals 0. But guess what? X squared, we've been dealing with this forever. I can either factor, complete the square, or put it in a quadratic formula to find my next 2 zeros. I'm going to put it in the quadratic formula. But what would make it easier to plug this in the quadratic formula? A calculator. But what would go quicker, yeah? If I took a 3 out of everything. And since it's equal to 0, I'm just going to divide both sides by 3. That's going to make our life a little easier, right? Because now we have a lower a term. My b is -2. Minus 4 equals 0. Let's throw this in the quadratic formula. Quadratic formula is x equals -b. So that's -2 plus or minus the square root of b squared minus 4ac, which is 4 times 1 times -4, all over 2a. Well, my a is actually 1. I believe this comes out to spoiler alert, 2 plus or minus the square root of 20 divided by 2. If you've done it, you can... Does anyone concur with that? Okay, good. But we can simplify further because square root of 20, we can reduce that down to 2 square root of 5. I think I'm going to run out of room again. So I'm going to come down here, equals 2 plus or minus 2 square root of 5 over 2. I can go one step further. You got bonus points on the test for doing this because this is nice, especially here. I have 1 plus or minus square root of 5. So I have 3 zeros. We have x equals 2 over 3. And we have x equals 1 plus or minus square root, not square root of 3. Who would write that? 5. Fair enough. So I have 3 zeros, right?
Yeah.
I have a 3 here. Think that means anything?
Yes.
I don't know. We'll find out tomorrow. Coincidence? I don't think so, but you gotta wait till tomorrow to figure out if it is. But it's not. Yes?
So, should we write these as fractions on test? Because, we can plug it into our calculator and just make it a fraction, make it pretty.
Make what a fraction? I'm sorry.
1 minus radical 5 or 1 plus radical 5 tells make it a fraction, so it's something that's not ugly.
Shh. Why would I make this a fraction, I guess?
I don't know, because 2/3 is. So I don't know if you want it uniform, with all the 2/3.
Oh, no. This is a number. This is a number. This is my exact version of it, simplified. Yeah, don't leave it as a fraction.
Okay.
Josia.
So, have any of the other numbers work from the base that we had?
None of the other numbers would work. Because it, in fact, only has one rational solution, and that is 2/3. This isn't rational because it's got a square root of 5 in it. So you would have went through that whole list and found out that only 2/3 work. So my advice to you is as soon as you find 1 0 that works, use it just like we did here to break it down to a quadratic, and then go from there. Does that make sense? Good. Nick?
And if you do 1 plus square root of 5, you get 3.2, and that's what it looks like on the graph.
Nice. But your graph would just give you the approximation, right?
Yeah.
Yep. This is our exact value. So you can check on your graph to make sure this is right, just like you just did. So what Nick just did is he actually did 1 plus square root of 5, and then he checked to make sure that's about where that point was for the 0. So imagine you're on the test next week, and you're able to find your 3 zeros, and you can actually check to see if they're the right zeros.
My own test.
You could grade your own test, and you could just put 100 right on the top. All right, real quick, your homework. Your homework, the first 2 problems are just what we did the first thing of class. You are going to determine if it is a factor. If it is a factor, you have to factor it fully. So hint, hint, they both are factorable, and they'll turn into a binomial times a binomial times a binomial. 35, 37, 39, and 41 do not work too hard. That is just asking you if it actually goes in evenly. So determine whether the number is a 0. So if your remainder is 0, you just say yes. If your remainder is not 0, you just say no, and you move on to the next problem. That's all it's asking. 51, 53, 57, all the way to 65. That is the one where I want you to list all your potential zeros. Use your calculator to come up with 1. For sure, that's going to work. Check it, and then use that to come up with your next 2. Does that make sense? If it doesn't work, it just means it wasn't one of your rational ones. Try a different one. Okay? Go ahead and get started. Yes, you need a bathroom.